Hi guys, today we're going to be doing a lesson on periodic trends, so looking at the trends across the periodic table. By the end of the lesson you should be able to predict the reactions of elements from their position in the periodic table. You should be able to explain why the trends down the groups 1 and group 7 are different, and be able to explain the changes across a period. So for our starter, it's something a little bit different. What I would like you to do is devise a mark scheme for the following question and give the answer that I've provided a mark using your mark scheme. So the question that I'd like us to look at is describe and explain how chlorine and magnesium react to form an ionic compound. Then the answer you're going to be marking using a mark scheme that you devise is, first, the chlorine atom loses an electron, giving it a -1 charge. This attracts electrostatically to the magnesium that has lost 2 electrons and forms an ionic bond. An extension then is I'd like you to answer that question perfectly to score full marks using your mark scheme. Okay, paying a lot of attention to the 2 words at the start, describe and explain. Okay, so your mark scheme should take into account what those 2 command words are actually asking you to do. Pause the video here, give yourself 5 to 10 minutes to have a go at that starter. Okay, the answer that I've got. So I thought it was a 6-mark question. So our first mark for saying that chlorine gains 1 electron. We've got to be specific with how many electrons. So chlorine is going to gain 1 electron. Second mark for saying it forms a -1 charge. Third mark for saying magnesium loses 2 electrons. Of course, magnesium is in group 2, so there's 2 electrons in the outer shell, so that's how many it will lose. Thinking back to C2.2. Fourth mark for saying it forms a +2 charge once it's lost those 2 electrons. Fourth mark for saying that 2 chlorines are needed to bond with 1 magnesium, so the final compound is overall neutral. Because if we have 1 magnesium with a +2 charge, we're going to need 2 negative chlorines to balance it out overall and make it a neutral compound. Our final mark for saying the chlorine and magnesium will attract electrostatically. Okay, so for this answer down at the bottom, I gave its first mark for saying that it has a -1 charge. In that first sentence, there's actually a mistake. It says that chlorine atom loses an electron. Of course, we know that's not true. Chlorine is a non-metal, so we'll gain an electron, and it will give it a -1 charge. So 1 mark for saying it's a -1 charge. So this attracts electrostatically, 1 mark for saying they attract electrostatically to the magnesium that has lost 2 electrons. So 1 mark for saying it has lost 2 electrons. So I think overall that's got 3 marks in total. Okay, so what I would like you to do first is have a think. Which group 1 metal and group 7 non-metal would react together most violently? So thinking back to the previous lessons, what are the most reactive elements in each group? Okay, so the answer is the reaction between cesium and fluorine. Now some of you might be a bit confused by that, saying, oh, cesium, well that's not the lowest down in group 1, what about francium? Well, you can't choose francium because all of its isotopes are radioactive and decay very, very rapidly. So that means it's impossible to actually have enough of it to react with fluorine. It would just decay before we could even react it. So unfortunately we can't choose francium. So we're going to watch a little video of the reaction between cesium and fluorine now.
Most reactive elements in the periodic table. Pig. We've got fluorine, the most reactive non-metal, and cesium, the most reactive metal. That's flushing through again. Yeah, looks good. Right, are we nearly ready? I'll lower this.
Yeah,
you look after your pipes. incredibly beautiful reaction there between cesium and fluorine, this intense light, and I don't think many people have seen that before.
Okay, so really quite a beautiful reaction there. Obviously gives off a very bright light, and it'll give off a lot of heat as well, because it's two very, very reactive elements combining together. Okay, so just a little reminder from previous lessons, and hopefully from C2.2, we can predict how an element will react by looking at its position in the periodic table because of its electronic structure. So looking at a metal, if it's lower down the group, it's going to be more reactive. The reason for that is it's got more shells of electrons, so your outer electron is further away from the nucleus. If your outer electron is further away from the nucleus, it's easier to lose it. And remember, a lot of metals will react by losing their outer electrons. Okay, so the easier it is to do this, the more reactive it is. Because all atoms ever want is a full outer shell. So all atoms are going to gain or lose electrons to make that happen. Okay, so we're going to look at two examples here. What I'd like you to do is, using the fact that groups 1, 2 and 3 elements lose electrons when they react, I want you to tell me which one loses its outer electrons more easily, and I want you to explain why. Okay, so pause the video here. I'd like a fairly lengthy sentence or a little paragraph in your book. Give that a go. Got about 3 or 4 minutes to do that. Okay, so sodium is the more reactive out of the two because it's further down group 1. The electron is further away from the nucleus, so it doesn't feel that positive charge from the nucleus as easily. So it means the electron is easier to lose, so it will be more reactive. Okay? Whereas lithium, which was our other example, it only has 2 shells, so this outer electron is quite close to the nucleus. So it's going to be more difficult to lose it, so it's going to be less reactive. Okay, looking at non-metals now. With group 7, they like to do the opposite of group 1. Instead of losing electrons, they like to gain electrons because they already have a nearly full outer shell, so it's easier to gain 1 electron in group 7 to get that full 8 rather than losing all 7. Okay? So bearing in mind that they gain electrons, why are smaller non-metal atoms more reactive? So why is this fluorine on the left-hand side more reactive than chlorine on the right-hand side? Again, pause here, write your answer in your books. You have about 3 or 4 minutes to do so. Okay, so as we said, non-metals want to do the opposite of metals. Non-metals want to gain electrons, while metals want to lose electrons. If you have a smaller non-metal, there's fewer shells in the way to shield the positive charge of the nucleus. So the electron is more easily attracted to the nucleus and it's more easily gained by the atom. So in other words, that electron is going to be coming to a shell closer to the nucleus, which means it's going to feel that attraction of the nucleus more. It's going to be gained more easily. Okay? And if it's gained more easily, it's going to be more reactive. Okay, you've got 9 minutes to have a go at worksheet 4.5. Should be attached on Show My Homework. So once you've done that, come back to the video and we'll go through the answers. So pause it here. Okay, get a green pen at the ready. I'm going to go through some of those answers. So, answer to question 1 is they lose their outer electron. Question 2, sodium. because it's further away from the nucleus. Question 3. Potassium's outer electron is further away from the nucleus. Question 4. They attract an electron into their outer shell. Question 5 is chlorine. Question 6. Its outer shell is closer to the nucleus, so it attracts electrons more strongly. Okay, another quick task for you. I would like you to have a go at answering these 3 questions. Again, pause it here. When you're done, we're going to go through those answers. So, question 1. Explain why the element cesium in group 1 is more reactive than potassium. So it's because cesium is lower down the group than, well, that should say potassium. Cesium's outer electron is further away from the nucleus than the outer electron of potassium, so it experiences less pull from the nucleus, so it's lost more easily. So why is astatine less reactive than chlorine? So it's because astatine has more electron shells than chlorine. The nucleus of astatine has a weaker pull on an electron trying to transfer in compared to chlorine, and so astatine is less reactive than chlorine. So astatine's outer shell is further away from the nucleus, so it's harder to put an electron in there. Okay, why is neon an unreactive element? Thinking all the way back to group 0. It's got a stable outer shell, so neither gains or loses electrons. So that makes it unreactive. Okay, going to look at a couple of trends in the periodic table now. So there's 2 that we're going to look at in total. Okay, we're looking at this atomic radii and how that changes as we go down or across a group. So first of all, what is an atomic radii or an atomic radius? It's basically how big the atom is. So the distance from one side of the atom to the other, and that's taking into account the basically the outer shell of electrons, because that is the biggest bit. Okay? So the first trend we're going to look at is probably the easiest one to picture. And we're going to look at this left-hand column here, the group 1 elements, to see what happens. So as I go down a group, so from hydrogen to lithium to sodium to potassium and further down, the atomic radius increases. Now the reason for this is quite simple, because as we go down each period, we get a whole other shell added on. So as I go from hydrogen, which only has 1 shell, to lithium, it gains a shell. So lithium has 2 shells. So sodium, being in period 3, will have 3 shells. Potassium, being in period 4, will have 4 shells. So it gets bigger as we go down, simply because we're adding shells. If you're not so sure about that, try drawing the electronic structures for those 4 and see if you can prove that for yourself. Now this second trend is a little bit more difficult to see, so we're going to go through it a little bit more slowly. So as I go across a period from left to right, so if we look at this second period here, from lithium to neon, what we see is the atomic radius actually decreases. So before we get into it, we're just going to remember right the way back to the start of year 9. If I have a positive charge and a negative charge, what are they going to do? They're going to try and attract. Okay, so we always remember that protons are positive, electrons are negative, and they feel some kind of attraction between each other. Okay, so with that in mind, as I go across the second period, we've got the same number of shells. We're not adding any new shells, we're obviously not taking any shells away. So both lithium, beryllium, boron, carbon, neon, oxygen, fluorine, and neon, they all have 2 shells. But as I go from left to right, the number of protons is increasing and the number of electrons is increasing. So neon has 1, 2, 3, 4, 5, 6, 7 more protons and 7 more electrons than lithium does. Now, remembering that there will be some attraction between the protons and electrons, if there's more protons and more electrons, there's going to be more attraction. So that attraction pulls the electrons a little bit closer to the nucleus. And if it's pulling the electrons a little bit closer, it's making that atom a little bit smaller. Okay, so very quickly, one more time, because I appreciate that one is quite difficult to get our heads around, so I'll go through it one more time. As I go across a period or a row, the atomic radius decreases because we add more electrons and more protons, but the number of shells stays the same. As the number of electrons and protons becomes greater, the attraction between them also increases, which pulls the electron shells in a little bit closer to the nucleus. Okay, and remembering the second trend, as I go down a group, you will add 1 extra shell for each row we go down. If we're adding a whole extra electron shell, it's obviously going to get a bit bigger. So I've attached a video there. If you're still a little bit unsure, it's absolutely fine. Just have a watch of the first part of that video and that should help explain it in maybe different words than I've used. Okay, a task for you now. I'd like you to use a maximum of 30 words, describe what happens to the atomic radius as we go down and across the periodic table, and then try and explain why. The reason I want you to use 30 words or less is we're trying to get those answers more concise, because in an exam you're obviously going to be wanting to write as few words as possible but still hitting all the key points. So try and be as concise as possible. Okay, so last but not least, we're going to look at and kind of recap just 3 little trends that we have actually seen in previous lessons. So first of all, we know it's easier to lose electrons when there are fewer electrons in the outer shell. So if we look at, for example, sodium and magnesium in group 1 and 2 respectively, the group 1 element, sodium, is going to find it much easier to lose its electrons, just simply because there's fewer of them. Whereas magnesium, because it's got 2 electrons in the outer shell, it's harder to lose them. So the fewer electrons there are, the easier it is to lose them. It's also easier to gain electrons when the outer shell is more full. So, for example, if you're in group 7, you only need to gain 1 electron. That's quite easy to do. Whereas if you're in group 6, you've got to gain 2 electrons to get a full outer shell, and that's just that little bit harder to do. Last but not least, the further away an electron is from the nucleus, the easier it is to lose. So we've seen that before when looking at group 1 elements, and a couple of times in this lesson as well, but just to remind you. Okay, absolute last thing I need you to do is our plenary. I want you to give 2 reasons why group 2 metals are generally less reactive than group 1 elements. Pause the video here, give yourself about 5 minutes, and then we're going to go through some answers. Okay, 2 reasons. First of all, the outer electrons are closer to the nucleus in group 2 elements, making them harder to lose. And second of all, there's 2 electrons to lose rather than 1 in group 2 elements, which obviously makes it harder to lose them. Okay, that's a fantastic job, guys. I'll see you next lesson.